Good evening, Jamie.
Evening, sir.
All right, how are you doing?
I'm good.
All right, good to hear, good to hear. Sorry for the short notice about today, but I have to actually leave. I have to go on the road about 7:15 or so. So that's why I asked to bump up class 30 minutes earlier today. So sorry for the late notice, all right?
Yeah, that's fine.
All right. So today we're going to be doing trigonometry. All right, so we're going to be doing trigonometry, and I sent the documents and a lot of classwork. We're going to be doing trigonometry for 2 weeks because there are many ways that the equations can come for you to solve. But it's a very, let me tell you from now, trigonometry is a nice topic. All right, it's a nice topic. It's way nicer than what you'd have been accustomed to from CSEC. All right, so it's really nice. So when you hear the word trigonometry, can you tell me what comes to your mind?
Geometry of triangles.
Geometry of triangles, very good. Pretty much a study of triangles. All right. Now, for the integrated mathematics syllabus, the only thing that we're actually required to be able to do is, oh, I didn't send you this classwork, trigonometry classwork 1. All right, I'm gonna have to send you this one. All right, so trigonometry, as you rightfully said, it involves just studying triangle. All right. Now, for the integrated mathematics syllabus, luckily, pretty much what they want us to focus on is just finding the sine and cosine and the tangent of angles. And also we need to be able to convert from degrees to radians, which we're going to talk about. Then we need to solve trigonometric equations of these forms. All right, and then we'll talk about the graphs of trigonometric functions. All right, and that's all we have to do on the trigonometry. So it's really short. This is all we need to know on the trigonometry. Now, of course, we're going to start with the most asked type of question, which is related to right angle triangle. All right. So, Jamie, what are the different types of triangles again?
You have scalene, isosceles, and equilateral.
All right, very good. So the types of triangles, you have scalene. And what is scalene?
It's when none of the angles are equal.
All right, very good. So scalene right here, this is when all the sides of the triangles are not equal in length, and also all the angles are not equal. All right, so that's scalene. None of the sides are equal in length. So different markings show that the lengths are different. Then you said the next one we have is isosceles. What's isosceles?
Two of the angles are equal.
All right, so two angles and two sides correspond to each other. So if this side angle is x and this side is also angle x, those two are equal in length. Very good. So that is isosceles. And then the next type of triangle you said is equilateral. And as the name suggests, all sides and angles are equal, right?
Yes, sir.
Now, I don't want us to just focus on these types. We can define the types of quadrilateral by lengths, or we can also define the quadrilateral by their angles. This is the one that I want you to focus on, defining them by their angles. So these same three triangles we can break up now as, sometime you're going to see the right angle triangle. That's when one angle is what, 90 degrees, right?
Yes, sir.
So this is the right angle. Then what are the other two types of triangles based on angles?
I can't remember these.
All right, no problem. The same one with scalene right there, we'd call that an acute triangle because all the angles in the triangles are less than 90. So if this is x, this is y, then all of them would be, there's no angle that is greater than 90. Maybe one is 50, one is 70, then another one is, I don't know, something else. But the three of them then add up to 180, right? So we call that a acute triangle. Acute angle triangle. So all the angles are less than 90. X is less than 90, Y is less than 90, and Z is less than 90. But at the end of the day, X plus Y plus Z, we know angles in a triangle sum to 180. Very good. And then the next type of triangle we have is, what's the next type of triangle based on angles?
Be obtuse.
Obtuse. Beautiful, Jamie. Beautiful. So that triangle is when one angle in the triangle is greater than 90 degrees. So this angle here is X. That angle would be greater than 90 degrees. The other two are less. Well, at least one angle is greater than 90 degrees. And we call it a obtuse triangle. So of course, we're going to look at evaluating sine and cosine for the three different types of angles based on their type down here. But of course, we're going to start with a right angle. So do you remember anything from CSEC regarding the right angle triangle?
Sine, cosine, and tangent.
All right, very good. So tell me what you remember is sine, cosine, and tangent. What about sine, cosine, and tangent? I don't understand what that means.
Use SOHCAHTOA with the.
Oh, so you say SOHCAHTOA. What does SOHCAHTOA mean?
Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent.
Very good, very good. So whenever we have a right angle triangle, usually they would give us an angle inside of the triangle. We don't know what that angle is, let's call it theta. The angle opposite, the side opposite from that angle, we call it the opposite. So if this is, we'd say that A is the opposite. And then we would say that if theta is the angle below, the side below the angle, we call that the adjacent. Let's call the adjacent B. And the longest side, we tend to call that the hypotenuse. Adjacent. And then the longest side, we can call it C, is the hypotenuse. So very good, Jamie. Now look at this. Now, this is what we know. You also said to me that the sine of theta is opposite over hypotenuse, right? So in this case, we said the sine of theta is A over C, right, Jamie?
So
the cos of theta would be what?
Would be B over C.
Very good. And the tan of theta would be what?
Would be A over B.
A over B. Very good. Very good, Jamie. Very good. All right. Now, in that case, look at this, Jamie. Now, there's another theory that we would have learned from CSEC known as Pythagoras theorem. Sorry. Do you remember what Pythagoras theorem is, Jamie?
Yes, sir.
What is Pythagoras theorem?
It's that A squared equals B squared equals C squared.
All right. Well, generally, we say that the hypotenuse square, in this case, it would be C squared, is equal to A squared plus B squared, right?
Yes, sir.
All right. So it's always hypotenuse square, in other words. Hypotenuse square is equal to opposite square plus adjacent square. That is Pythagoras theorem. Now, Jamie, look at this. We're going to do something really amazing. From this equation right here, if I were to cross multiply the C, I can write that A is equal to C sine theta, right? Do you agree with that?
Yes, sir.
And look at this, Jamie. If I were to cross multiply the C in this equation, I would get that B is equal to C cos theta. Do you agree with that?
Yes, sir.
Now look at this, Jamie. In Pythagoras theorem, I'm going to combine Pythagoras theorem and trig ratios. This up here is known as trig ratios. Combining Pythagoras theorem and trig ratios, look at this. So this is saying c squared is equal to, replace a with c cos theta all square plus, replace this b, a was sine, c sine theta all square, and then replace this b right here with c cos theta all square. And notice this, Jamie. Notice what we get is c squared is equal to c sine theta square. You can write that as c squared times sine theta all square plus c squared times cos theta all square. Isn't that so, Jamie?
Yes, sir.
Now look at this. If we were to divide the entire equation by c squared, because sometimes you're solving an equation like this. Look at this. Let's say you're solving 2x plus 4 equal 8. Instead of solving this equation and then say 2x equal 4 and then divide by 2 to get x equal 2, you could just divide it through by 2 to simplify the equation to be x plus 2 equal 4, don't it? Isn't this and this equivalent, these two equations?
Yes, sir.
Yeah. So in the same way we're saying, let's clear this now. What we're saying is right here, if we divide through by c squared, we end up get a new equation that is saying c squared over c squared, that would become 1. And that, I don't want to squinge it. So c squared divided by c squared become 1. And when we divide this part by c squared, we're left back with sine theta all square. This part we're left back with cos theta all square. In this case, we're left back with 1 is equal to sine theta all square plus cos theta all square. All right. And this right here, Jamie, is the first identity that we must remember in trigonometry. All right. This is the first identity we must remember. So this right here tells us that the sine of the angle in the triangle plus the cos of the angle, the sum of their squares is equal to 1. Isn't that amazing?
Yes, sir. And I recognize this identity. But I didn't know how they got it.
Oh, you didn't know how they got it?
Yeah.
Okay, but now you see the proof. All we did was just combine the trig ratios, right?
Yes, sir.
Very good. Now look at this, Jamie, now. So after we combine the trig ratios, we get this identity, and we can also test it out with some numbers. So just to have the calculator here, maybe the angle is 30. You can put the sine of 30 square plus the cos of 30. We're just testing with an angle. It don't have to be 30. I want to use 30 square, and we're going to get 1. Now, it doesn't matter what the angle is. We're always going to get 1 because that's what the law says. So even if we use 55 and change the sign here to 55, as long as it's the same angle, we're going to get 1. So that's the first identity that we have right there. This is the first trig identity that we must know. All right, must know. It's in the notes, but, you know, for review, but at least we went through it and it feels good. Now, the next identity that we must know, I like us to see how they actually come about it. So from right here, we identified that you told me that tan theta is opposite over adjacent, right?
Yes, sir.
So look at this, tan theta is A over B. You told me that tan theta is A over B from the diagram. Now, Jamie, look at this. Didn't we say that A was C sine theta right here? I would say B was C cos theta.
Yes, sir.
Very good. And so the next important identity is going to be, look at this, C sine theta over C cos theta. Notice that the C, the C's cancel, right?
Yes, sir.
Very good. And so this is the next identity that we must remember, is that the sine of theta, the tan of theta is the sine of theta divided by the cos of theta. And we must know these two identities. These two we must know because at some point, we're going to be solving a trig equation that we're going to have to apply these, all right?
Right.
So that's the first two. That's the first two trig equations that we must know, all right? So it's all right here, pretty for us, all right? Defined and everything, but we must know. So we covered the first two right there. Now, the next thing we're going to talk about, Jamie, is what's known as equivalent angles. Now, I'm going to show you something. So look at this, Jamie. Sine 30. Put that in a calculator. Notice you get a half. And look at this, sine 150. Going to get a half as well. What? But notice if I put sine maybe 120, I'm going to get a half. Different answer now. So why sine 30 and sine 150 give the same answer? All right? Must be a reason, right?
This is the cast.
Yes, this is the cast. All right. I'm going to show you the simple proof of how it exists, how it came about. So a lot of teachers just tell you to remember cast, all right, but they don't go explicit into how it came about. That's why I asked you first and foremost, what is trigonometry? And you told me trigonometry is geometry of triangles. Very good. I'm glad that you used the word geometry. Jamie, you're really smart, you know. A lot of persons won't use that word, you know, they're just gonna say the study of triangles. But you see, when you use the word geometry, geometry can take place on a what? On a graph, don't it?
Yes, sir.
And on a graph means that we're gonna be in different quadrants, right?
Yes, sir.
All right, very good. So look at this. It's easy to work out trig ratios when you're always in the first quadrant. So in the first quadrant right here, if you have a triangle in the first quadrant, this is your angle. That's your angle right there, theta. Angle between the positive x-axis, that right here gives you the angle we're working with. If this is theta, notice in the first quadrant what happened, Jamie. The x-axis is what? Positive, right?
Yes, sir.
The x is positive and the y is positive. All right, so the x is positive and the y is positive. So in that case, Jamie, because let's say this length is B, this length is A, and this is still C. So still working with our opposite, adjacent, hypotenuse. In this case, sine theta is going to be greater than 0. It's going to be positive, right? Because notice that we'd have opposite being positive over hypotenuse is positive, and positive number over positive number give a positive result, right?
Yes, sir.
In the first quadrant, since everything is positive, sine will be positive, cos will also be positive, and tan will also be positive. And that is why we end up get that all the angles that you evaluate in the first quadrant are going to be positive. First quadrant just means that theta is between 0 and 90 degrees for your triangle, right?
Yes, sir.
Now let's move on to the second quadrant. Now, if you construct your triangle in the second quadrant, now look at this, Jamie. In the second quadrant, notice something irregular happened. The x is what now?
Negative.
The x is negative. The x is negative, Jamie, minus b. Wait a minute. Minus b. Now, in that case, Jamie, if this is your angle, theta, all right? If that is your angle, theta, this is your opposite, A. Let's say the adjacent is just B, right? Not gonna say negative B. In this case, we're saying that A would be greater than 0 because it's still a Y value. C will be positive because hypotenuse is just A squared plus B squared, right? And when you square any number, it's gonna be positive. So the hypotenuse will always be positive no matter what, right?
Sure.
Nice. And in this case, B is less than 0. So because B is less than 0, Jamie, notice right here that sine is then going to be positive because sine is what? Opposite A over hypotenuse. Cos is then going to be what? Cos is negative, right?
Yes, sir.
Cos is negative because as we can see, the adjacent would be negative. We'd have B over C, but B is negative and negative over positive is negative. So that's the reason why cos ended up being negative. And the tan,
It
which
will
is
also be negative.
tan will also be negative because tan, we said, is sine over cos. And so you're dividing by negative, so it's negative. So notice in the first quadrant, Jamie, that we end up get all of them to be positive here, just sine to be positive here. And if you follow the same, we're not going to draw up the triangle anymore for the others. Pretty much are down here, tan going to be positive because down here, x is negative, y is negative, but negative over negative be positive because tan is sine over cos, right?
Yes, sir.
So down here, this is how we get the tan to be positive, the others are negative. And then down in this quadrant, the cos going to be positive. And that's how you end up get the cast, C-A-S-T. All right, all you do is construct triangles, and then that tell you which angle is positive in which quadrant, all right?
Yes, sir.
Now, how did we come about with this equivalence angle now? Now, this is where the equivalence angle came about. Now, in Jamie, in the second quadrant, even though this is the angle within the triangle, now notice from complex numbers, we always say that we work out angle between the positive real axis. So what we're then saying is, in order to find the equivalence of maybe a sine 30 degrees, when you're in the second quadrant, even though let's say this is 30, what you'd actually take is the angle between the triangle and the positive real axis. The positive real would be all of this angle. If this is the 30, then all of this right here would be the positive real. This would be the angle between the triangle and the positive real axis, right?
Yes, sir.
And that's how you come up with the 150. In other words, we end up would say that the sine of 150 would be equal to the sine of 30. It's just that we're equating angle between the positive real axis in each of the different quadrants. So these are all the formulas, not to go through all of the proofs technically, right? But I just want you to understand where it came from, because you see we're linking the different topics, complex numbers, and now trigonometry, always angle between positive real axis, right?
Yes, sir.
Nice. So in this case now, Jamie, just to summarize what the results are going to be, the results that we're going to get is that sine, we already know where it is positive. Sine is positive in the first and the second quadrant. And so in that case, we're saying that the sine of theta right here is equivalent to the sine of 180 minus theta. That's the first thing that we must remember. And these are when sine are going to be positive. And this is, of course, where theta is an angle in the first quadrant, where theta is between 0 and 90 degrees. So the sine of theta is equal to the sine of 180 minus theta. Now for the cosine now, the cos of theta is going to be equal to, now where cos is positive again would be down here. So if cos is positive down here and cos is positive up here, that's where we're going to get our equivalence angle. So in that case, now we're going to say that the cos of theta is equal to the cos of 360 minus the angle in the first quadrant, theta. And then the tan of theta is equal to, tan is positive all the way over here. So that is where in the third quadrant, it's going to be the tan of 180 plus theta. All right, that's how you get your angle in the third quadrant, 180 plus theta. And those are the positive sine, cosine, and tan values. Now, when they're negative, now if theta is between 0 and 90 degrees, then the negative angle is going to be, we need to be in the third and the fourth quadrant. So the negative sine values that are equivalent is the sine of 180 plus theta. That's going to be equal to the sine of 360 minus theta. And these are going to be negative values. the cos of 180 minus theta, that's going to be equal to the cos of 180 plus theta. And then down here, the tan of theta, the tan of 180 minus theta, sorry, is going to be equivalent to the tan of 360 minus theta. And of course, as I said, all of these are going to give us negative values. All right, all of those are going to give us negative values. Cool?
Yes, sir.
So, for example, all right, let me allow you to evaluate some sine values then. All right, so before I give you the sine, cosine, and tan values, I want you to evaluate. Now, Jamie, next thing that you must remember is there are some values that you must know. All right, so I'm going to give you the table that you must know. Right? They're not going to tell you that you must know them, but it make your life really easy if you know them. All right? If you know, but of course, if you have special calculator, you don't need to know them, but these are some values that you must know. When theta is 30 degrees, 60 degrees, 90 degrees, 180 degrees.
Just the pi over.
Oh, yes. Well, yes. Well, we don't convert to radians yet. We still call it pi by 6, pi by 3, pi by 2, pi. We soon call it that for now. But for now, let's work with it in degrees, all right?
Okay.
All right, so these are the tables that you must know, Jamie. You must know these values mentally or be able to remember them because it makes your life way easier. So for example, let's say you're asked to evaluate the sine of 30 degrees. When it is 30, the sine of 30 degrees is a half. If you wanted the cos of 30 degrees, the cos of 30 degrees is root 3 over 2. All right? Then the tan of 30 degrees, the tan of 30 degrees, well, for me, once you remember sine and cos, you're good because you can always then work out tan. You can always then say tan 30 is sine 30 divided by cos 30, root 3 over 2, which is a half multiplied by 2 over root 3. That would give you 1 over root 3, or some people like to write root 3 over 3. I generally don't remember the tan one mentally because I know that tan is sine over cos. But it's good to remember the sine and cos values especially. Then the sine of 60 is going to be root 3 over 2, and the cos of 60 is going to be a half. So then to find the tan of 60, you're now just dividing a half by root 3 over 2, which is a half multiplied by root 3 over 2 is 2 over root 3. This cancel this. What I say we're dividing? Oh, root 3 sine over cos, root 3 over 2 divided by a half, which is same as multiplying by 2. In this case, tan 60 is root 3. Now the sine of 90 is 1, the cos of 90 is 0, and so the tan of 90, tan is going to be sine over cos, but 1 over 0 is undefined. So this is undefined. The tan of 90 we don't know. You can't put that into your calculator, it's undefined. Or some people like to call it infinity. Sine of 180 is going to be 0. The cos of 180 is negative 1. And then the tan of 180, tan is sine over cos. In that case, it's 0. The sine of 360 is 0. The cos of 360 is equal to 1. And the tan of 360 is 0. The sine of 0 is 0. The cos of 0 is 1. And the tan of 0 is also 0. You must know these values, Jamie, because it makes your life very easy if you remember them. All right? Makes your life very easy. Now, why do you need to know it? Because sometimes a question might come on the example as simple as this. Most times on the exam, it's going to be in radians, but on the paper one, Won't get to paper one, Jamie. Don't worry. I'll send you paper one to finish the syllabus for you to do mock exams and stuff like that. But on the paper one, for example, the last year paper one, they had the sine of 135 degrees. And they asked students to find out that. Now, automatically, 135 degrees is in which quadrant, Jamie?
Quadrant 2.
Quadrant 2, very good. So quadrant 2. So in quadrant 2, so if this angle, now we need to ask ourselves, 135, think about it this way. Always think about it being the angle between the positive real axis and the triangle. So what we're saying then is if this angle is 135, because we're in the second quadrant, but it's an angle between the positive real axis and the triangle, then in here it's equivalent to it would be equivalent to this angle in the first quadrant. In that case, we just said the sine of 135 is equal to the sine of 45. That, oh, I didn't put 45 in the table. You must know 45 as well. And 45 is root 2 over 2. So this is 45 degrees, and this will be root 2 over 2, root 2 over 2, and this is 1. So in that case, Jamie, on the paper one, this was the answer. It was just 1 over root 2, because they didn't put root 2 over 2. And so many, according to the CAPE syllabus, they said many persons didn't get this right. And all we had to remember was this, that the sine of theta is equal to the sine of 180 minus theta. In other words, we're saying if this part is 135, the sine of what number x is equal to the sine of 135. So 180 minus what number can give us 135? We can say 180 minus x is 135. So x must then be 45. So then we can then input that the sine of 45 is the sine of 180 minus 45, which is the sine of 135. And then that is the importance of knowing this, where we can then conclude that the sine of 135 is 1 over root 2 or root 2 over 2. All right? So that's the importance of knowing it. Right, Jamie?
Yes, sir.
So as I said, this is all you need to know for when sine is positive and when it is negative. So now I'm going to give you some questions. Let me allow you to write on the screen. These are some values that I want you to evaluate for me.
Wait, sir.
Yeah.
How is root 2 over 2 equal to 1 over
1 over root 2? All right, no problem. So remember when we did thirds and we rationalized? Look at this, root 2 over 2. Now look at this, the 1 over root 2, what we do is multiply by the conjugate. Now, the conjugate of root 2 by itself would just be root 2. So multiply by root 2 over root 2. 1 times root 2 is root 2, and root 2 times 2 is 2. So hence, that's how we end up get 1 over root 2 is equal to root 2 over 2. All right?
Okay.
So many persons who study the formulas will study this. But what they decided to do on the CAPE paper last year was put this as the option. But all you had to do was rationalize. All right? Just multiply by root 2 over root 2. So don't worry about that. You know, as we're doing past papers and I give you the full paper to do, yeah, you'll see through these little disguise that they do. Because I have all the papers, I have all the paper tools now, and I only have one paper one missing. I don't get the 2016 paper one yet. So when we finish SB and syllabus and you're doing past papers, because Jamie, remember, you know, we're going for the placement, you know,
Yes,
right?
sir.
We're going for placement. That's what we want. So definitely. So that's what we're going to be doing. All right, so now let me allow you to, okay, I allowed you to share your screen. So I'm gonna ask you to evaluate these angles for me now. So you can share your screen and write down these. Want you to work out the cosine of 135. Yeah, that's the first one. Or you get minus root 2 over 2.
I just put it in the calculator.
All right. All right. I wanted you to tell me the equivalent angles, but no problem. All right. That is correct. All right. All right. Yeah, forget that you have smart calculator. The tan of 315 degrees. It's -1.
Yes, sir.
All right, now here's the reason why I don't like when you just put it in the calculator, because what if it was a paper 2 question? So first thing I want you to do is tell me cos 135. 135 is in which quadrant?
It's in quadrant 2.
This quadrant 2. Now when you're in quadrant 2, right? Which equate that mean the cos is what? Positive or negative?
It's negative.
Negative. Now the cos of 135 is equivalent to what? So which equation would you use if it's negative?
Which equation? It's 180 minus theta.
All right, so in this case, we'd say that the cos of theta is equal to negative the cos of 180 minus theta. Because he said that in the second quadrant, it's negative, right? Put a bracket around 180 minus theta. Yeah, that's what that's what we're actually saying. The cos of theta is negative the cos of 180 minus theta. So in that case, we need to find out what theta is, right? If you set 180 minus theta to be 135, what would you get? You'd get theta to be?
45.
45. So now when you get theta to be 45, you then write down the cos of 45 is equal to negative the cos of 135. Then you make the cos of 135 the subject. All right? All right, cool. All right, now, Jamie, now we're going to be doing some trig equations. This is very popular, but we're going to be starting very, let me see. All right, no. All right, I'm going to take access of the share right now. And then we're going to do 2 questions and show you how we're going to use all of this knowledge now to solve trig equations. And then afterwards, I'm going to give you some questions to do. All right?
All right.
All right, great. All right, so Jamie, here I have some questions. I don't send you this worksheet as yet, but don't worry, I'm going to send you. These are some questions that they can give us to solve, which are some trig equations questions, all right? So It looks very simple. It looks very basic. Now, is it going to be that basic? Let's find out. So we're going to do the first one together. It says solve 4 sine a half theta times the cos of theta equal 3 cos theta. And it says find all the angles between 0 and 360.
Wait, sir.
Yeah.
So you don't have the 2016 paper one?
No, I don't have the 2016 paper one, but I have the others.
I just found it.
Oh, you found it?
Yeah.
Okay, great. All right, great. So you can share it with me. And then, of course, when we start past papers, you're going to do them in full. All right? But I have all the others, though. I have the 2018, 2019. Okay, great. Thank you. All right. All right. All right. With that being said, let's go now. Let's go. All right, let me save it. Save. All right, thank you. All right, let's do this first one now. It says 4 sine a half theta cos theta equal 3 cos theta, and they say find theta. All right, so it looks fairly simple, but it's not going to be that simple. I guarantee you. 4 sine a half theta times cos theta equal to 3 cos theta. So Jamie, what's the first thing that's coming to your mind to solve this equation?
The 4 in front of the sine.
Factor out?
Oh, factor out. You can factor out theta.
We can't factor out theta like that. Theta is not a variable to factor out. Remember, the sine of theta comes as one thing. So anytime you say sine something, always look at it as one thing. It's really sine of this, cos of this. We can't factor out theta. Because the cos of theta is the angle and the sine of theta is the angle, right?
So we can factor out the half because it can go to 4.
All right, so we can't factor out the half theta either. So remember, you have to look at it like this. Sine, think of half theta as like a y times the cos of theta as like a x. You couldn't factor out it. Couldn't do that. So this is what we're going to do, Jamie. Anytime it's not the same angle, half theta and theta is 2 different numbers. So we can't factor out anything until they're the same. So this is what we would do. Notice this is 3 cos theta. Oh, look at this, Jamie. I can write this as 4 sine a half theta times the cos of theta minus 3 cos theta equals 0. Doesn't that make sense?
Yes, sir.
Now look at this, Jamie. I notice that, wait a minute, this is one term and this is another term, right? Right, Jamie? So we can, that's one term and this is another term, right?
Yes, sir.
So we can factor out a cos theta now, and we'd be left back with 4 sine a half theta minus 3. Isn't that beautiful? Equals 0. Now, this is something that we can solve now, right?
Yes, sir.
No, Jamie, when the product of 2 numbers is 0, if you have A times B equals 0, then it's either A is 0 or B is 0, don't it?
Yes, sir.
So now we solve either cos theta equals 0 or the 4 sine a half theta minus 3 equals 0. In that case, Jamie, let's start with solving the cos theta equals 0. So first thing, Jamie, is we know that there are always going to be 2 answers. When you're between 0 and 360, is 2 answers. So what I want you to do is draw your circle and write down your cast. C-A-S-T. That's not how I learned it. I learned it to say all schools teach crap. First quadrant, all. Second quadrant, school. Third quadrant, teach crap. All schools teach crap. That's how I learned it. All right? All schools just teach crap. But no problem learning the crap. In this case now, it says if cos theta is 0, right? Because 0 is, of course, you can't say it's negative. So we're going to be in the first and the fourth quadrant because 0 is positive, right? Well, it's not positive or negative, but since it's not negative, we're not going to associate it with the negative quadrants. So in this case now, we can first find the angle in the first quadrant, which would be theta equal cos inverse of 0. And cos inverse of 0 is, what's cos inverse of 0? 90, very good, because we said cos 90 was 0. So if the angle in the first quadrant is 90, we said the equivalent angle in the fourth quadrant was 360 minus the first quadrant angle, right?
Yes, sir.
So 360 minus 90, which would give us 270. So in other words, we get two answers already. We get that two possible answers are, so let's just write it up here for now. So we get two possible answers are 90 and 270 degrees. Now, Jamie, let's find the others now. So from this equation, if you were to solve it, then bring over the 3, we would get 4 sine a half theta is equal to 3, right?
Yes, sir.
Then we can divide through by 4 to have the sine of a half theta is 3 out of 4. Yeah?
Yes, sir.
All right, so if what the sine of a half theta is 3 out of 4, what we can then do is say, wait a minute, sine of half theta is a 4, we draw a circle and notice that 3/4 is a positive number. Positive opposite, positive hypotenuse. So that means we're in the first and the second quadrant because that's where sine is positive, right?
Yes, sir.
So in the first quadrant now, to get the angle, now Jamie, look at this. I'm going to write a half theta is sine inverse 3/4. Notice I say a half theta, right? Half theta because it's a half theta here, right?
Yes, sir.
And so a half theta is 3/4, or a half theta is, it would be 180 minus whatever this answer is. So what's sine inverse of 3/4, Jamie?
It's 48.6.
48.6 degrees, good. And then in this case, we have a half of theta, which would be 180 minus 48.6 degrees. So what does that work out to be? 120, 130, 131.4?
Yes, sir.
131.4 degrees. But that's a half theta. A half of it is this. So if we multiply it through by 2, we get the full answer for theta. So timesing it by 2, we're going to get theta equal 48.6 times 2. I think that's 97.2. Is that correct? 48.6 times 2?
Yes, sir.
And then the next one would be 262.8. So finally, all the answers would be theta is equal to 90 degrees, 97.2 degrees, 262.8 degrees, and 270 degrees. Notice that I give them the answer in ascending order. You don't have to, but I like when you write all the answers in ascending order. So it's pretty. All right. So you cool with that, Jamie?
Yes, sir.
Now, last thing I want to do is to test it out right here. So let's test it out for them. So we got that theta was 97.2. I think 90. We got 270 and 262.8. So just to test them out, Jamie, as you can see, for I'm going to bring up the calculator. So I brought up the calculator. That means when you put in theta on both sides, it should be equal. Testing it with the exact numbers first, the 90. 4 times the sine of a half of 90. A half of 90 degrees, close up that bracket, times the cos of 90. Notice when I put this in, I'm going to get 0. And then on the right side, if I put in the 90, 3 cos 90, I get 0. So notice that when 90 go in, we get that the two sides definitely give us 0, right, Jamie?
Yes, sir.
Nice. Now, look at this now. If we put in the 270, likewise, it's going to work. So not even bother going to put in the 270 because we know those are the equivalent angles. Cos 270 going to be 0. So this side would be 0 and this side would be 0. So let's check with the 97.2. Now remember, we rounded off, so it might not necessarily be exact to each other. But look at it now. 4 times the sine of, in bracket, a half. Put the angle as 97.2. And then we have times the cos of 97.2. We'll put that in our calculator, we'll get negative 0.376. So putting it over here, we're supposed to get this same answer, right? Negative 0.376. So let's check it out. 3 times the cos of 97.2, negative 0.37. As I said, it's not exact because we rounded it off. So if you had written it to maybe 10 decimal places, it would have been much closer, right? So notice both of them is roughly negative 0.37. One was negative 0.376, one is negative 0.375999, which is still 376. And you can test it out with 262 as well. So now you realize all the answers are correct, right?
Yes, sir.
All right. So as I said, Jamie, they just try to give a little bit. They try to give a little bit of a trick because a question like this, all you had to do was use little factorization, all right? So all you had to do was bring over the 3 cos theta and then solve. So look at the second one now. There's a little trick to it of how you'd go about solving this. Sine cube x plus 8 cos cube x equals 0. Go ahead and solve this for me, Jamie. What's coming to your mind, Jamie? What do you notice about sine cube and cos cube? What's happening there? They're both being cube, right?
Yes, sir.
Now, can you solve an equation with sine and cos in it? Usually you just want to have either sine alone or cos alone, right?
Yes, sir.
How do you think you can just make it be one variable? What's coming to your mind? Gonna give you a hint. Divide through by cos cube.
Oh, so this would just give me tan.
Tan cube. Yeah, so write that down. All right, now look at that, Jamie. If you have tan cube, can you really do an equation with the cube now? How can you get rid of the cube now? Because that's fine now. How can you get rid of the cube? Cube root it, exactly. So cube root both sides. Yeah. Cube root of -8. Good, good. No, no, anytime I get to this stage, I want you to draw the circle first, because notice you're getting a -2. So I want you to show me which quadrant the angle should be in. Yeah. When is tan going to be negative?
So the up here, but negative.
Very good. The second and the fourth. Good. The second and the fourth. Good. You're right. So first you have to find the angle in the first quadrant though, so before you can find the angle in the second and the fourth. No, do what you were doing first, man. Find the angle in the first quadrant. X equal tan inverse of what you were doing. Tan inverse of 2. Don't put -2 though, you know, put 2. Yeah, put 2. Yeah, that's going to give you a number in the first quadrant. You're going to get 63.4. Now, Jamie, when you get this answer now, I want you to tell them, but no, we know that the angle is in the second and the fourth quadrant. So you could then write it in words and tell them, but the angle is in second and fourth quadrant. And so x equal, then you give them the true x values. So the second quadrant will be it's always 180 minus. Good.
So why do we use tan of 2?
All right. Now, why do we use the tan of 2? No, we use the tan of 2 because generally what we call it is the principal acute angle. So anytime you're going to evaluate the inverse, I say find the principal acute angle, which is the angle in the first quadrant. Once you find the angle in the first quadrant, that is the safety net that you can use to find the angle in any other quadrant. But if you take sine inverse first, right? That's only going to give you, put in sine inverse -2. Tell me what you're gonna get. Tan inverse -2. Tell me what you're gonna get.
Yeah, negative 63.
Exactly, but remember what the question had said. I'm just gonna go back to share screen for a second. Remember they said the angle must be between 0 and 360. Negative 63 is what? Less than 0, don't it?
Yes, sir.
So in order to start from 0, you know that you can't be going in the anti-clockwise direction. You can't be with the negative angle. So in order to evaluate that process, what you do is find the first quadrant angle, but then find the equivalence in the other quadrants. Because then we know that in the second quadrant, when it's actually negative, it's 180 minus the first quadrant answer. And then in the fourth quadrant, when tan is negative, it's 360 minus the first quadrant answer, right?
Okay, yes, sir.
Yeah, so always find the first quadrant answer, and then we can use that as a safety net to find the other answers based on what we want, right?
Yes, sir.
Make sense? Good. So you can now check it with a calculator. So share back screen now and find the other one. Okay, found both of them. So check it in a calculator now. In the original equation, sine cube of 116.57 plus 8 cos cube of 116.57. Guarantee you're going to get 0 point something. That's because that is true. I'm going to go with 116.57. I want sine cube of that. Plus cos cube of it. You put in the calculator?
Yes, sir. I got negative 4.6 something times 10 to the negative 4. I think I put it in wrong.
No, that's a very small number. That's good. That shows that it's approximately 0. Remember, 10 to the negative something, that's very small, you know, that's 0.00000000004 something. That's good. That's what it's supposed to get. Remember, we round off, so we're not getting the exact values. All right? We're not getting the exact values. Yeah. So that's very, very, very correct. All right? So I'm just going to show you in Symbolab here. Let Symbolab solve it and show you they're able to give the exact values. We're going to be able to give the exact values soon too when we're looking at the radians, all right? We'll be able to give a more accurate reading in radians. So just checking out Symbolab here, just going to show you, and then you go back to the rest of them. If you're solving, what was it again? Sine cube?
Sine cube x plus 8 cos cube x.
8 cos cube?
Yes, sir.
Or sine cube x plus 8 cos cube x, and that is equal to 0. All right, okay, great. All right, Symbolab is very slow today. My gosh. Oh my God. They can't solve it. That's disappointing. That's really disappointing. All right. I wanted to show you how they round it off to get somewhere closer to it, but since Symbolab won't do it, let me see if this does it. So there's another one known as Mathway. I said these are just perfect tools that you can use whenever maybe you're bored and you want to make up some question, they check to see if the solution is verified. But you never have to make up question when I give you so many questions to do. that are always enjoyable. But let's say sine cube x plus 8 cos cube x equal to 0. Let me see if they can solve it. If they can't, that's disappointing. Unable to solve. Yeah, this is really disappointing because they should have been able to solve. I have a calculator that can do it, but it's not on this computer. Which calculator do you have?
The Casio FX 115.
Beautiful, you're good. You have the 1151. What I want you to do is go to mode. Click on mode on your calculator. You're going to see equations, right? I think it's number 5, right?
Yes, sir.
So you can then type in the equation, but don't remember which one is a trig function. All right, next class, I'm gonna have the 115 up and show you. So these questions too, why am I showing you this? Is when you go into the exam, Jamie, I want you to even work it out, get the answer right, check it with the calculator, and make sure you're getting everything right. So trust me, on the paper too, you're gonna get 100. We're going for 100. I'm going to show you how you can do everything on the paper too with your calculator. Your calculator can even do statistics. All right, so there's nothing that you're not going to get on the paper too. But don't worry. So share your screen again now. And you're going to do the third part now. Question number 3. All right, so question number 3, it says 8 sine square y is equal to 7 minus 2 cos y. Yep, solve that for me. What's coming to your mind, Jamie, of how to solve it?
Getting rid of the coefficient of the 2 by dividing it on both sides.
Getting rid of?
2 right there.
All right, now why would you get rid of the 2? You don't need to get rid of the 2. Notice that this have a sine and a cos. Can you solve with sine and cos? Don't need to erase anything, but we can't solve it with sine and cos. Last time, both of them had sine cube and cos cube, so it's easy to divide through. Now we can't divide through because they're not the same power, don't it?
Yes, sir.
You only can divide through when they're the same power. This is nowhere, Jamie. You're going to have to remember the identity we set up there. Sine square theta plus cos square theta equal 1. Write that down to the side of the paper. Yeah, exactly, man. So, Jamie, look at that. What if you were to make sine square theta the subject? In the equation right there, no, at the top, sine square theta plus cos square theta is 1. Make sine square the theta and sine square the subject in that equation. No, I'm not make sine square from here, not yet. I'm saying in that equation, sine square plus cos square is 1. Make sine square the subject right there first. No, the other equation on the right that I just asked you to write down. Yeah, make sine square the subject from there and observe what would happen. Very good, Jamie. Now look at that. Can't you replace now sine square theta in that equation? In the original question now, replace sine square with 1 minus cos square. That's nice, don't it? Now you're gonna have an equation with just cos, so now you're okay.
So you can't distribute trig ratios, right?
Yeah, distribute the 8. That's fine. Distributing the 8. Good. Now, Jamie, look at this. What if you were to call cos y j? Let's use j for Jamie. What if you were to call cos y j? So let cos y equal j. What do you notice? That equation would become what? Pop into the 8 before the j square.
Wait, this is looking like a...
Looks like a quadratic, right?
Yeah.
Yeah, so notice the trig equation is working out just to be a quadratic. Yeah. All right, you brought over the 8. How it becomes 15? I don't understand. You bring over 8, subtract 8. All right, now, Jamie, so when you have a negative in front of the 8j square, you never like when the first number is negative. So multiply through by -1, just to get rid of the negative in the first one, because the negative might make it difficult to factorize. Good, now we can factorize. So now to get 8, it must be 2 and 4, right? Good, but which one is going to get the plus and which one's going to get the minus? Let's see, it says signs are different and the bigger one going to get the negative, but both numbers going to be 1, right? The only two numbers they can multiply and get 1, it must be 1 and 1, right? So put the 1 and 1. So how you know which one is the bigger number is which one going to give you the bigger fraction now? The bigger fraction would be associated with, bigger fraction is between 4 and 2, that would be half and a quarter. Which one is the bigger fraction? The lesser fraction, or the bigger fraction, the lesser fraction, that look like 2j, 4j. Yeah. So the bigger one is, so 4j, the bigger one, the lesser one is 2j. So 2j, yeah, 2j get the minus. Because remember it's saying, and the bigger number get the negative. In that bracket, the bigger number, that's really saying j is a half. The other one would be a quarter. But bigger number would be the half, right? With fractions, it's a little weird, but you have to remember half is bigger than quarter, right?
That's right.
Yeah. So now you can go ahead and solve. Where you get -1? All right, so divide through by 2 now. So cost-wise a half. So in the first one, when cost-wise a half, first thing, draw your circle. Because that's a positive number, so cost is positive in those two quadrants. Good. So find those two angles now that correspond to the cost of the angle being a half. Cost inverse of a half, which we should know. That is, we say the cost of a number gave us a half. That number was?
Can't remember those yet.
No worries. Over time, as you look at the table more, you'll be able to remember those numbers. Yep, cos of 60. Remember, cos 60 is a half, sine 30 is a half. And then the next angle will be very good, 360 minus the 60, good. All right, put y equal that as well. Y equal 360 minus 60. Good, down there, yeah, good. All right, so we have 2 answers so far. Now you can find the other 2 answers. Very good. You find the first quadrant answer, but you need when it's negative. Let me see what you're gonna do now. Very good. 180 minus. $180 plus. Good. $255.5. Very good, Jamie. Very good. All right. So then finally list out all the answers. Very good. All right. Now, I just installed the calculator. So what I'm going to do, I install the one that you're using. I'm going to show you how you can put it directly in it. Let me see. All right. Oh. All right. Unfortunately, it can't work. It's not supported by this computer. All right. Guess I'll just have next week, I'll use the other computer. But those are all the answers right there. So that's good. So you can check it in a calculator now. When you put in sine 60, when you put in y of 60, you're gonna see it. Put in the cos of 60 and all of that. All right, you can check it and it's gonna be correct. All right, so how do you feel with those 3 questions, Jamie?
You have to really pay attention, but that's interesting.
All right, very good. And I have a lot more for you to do. They're pretty interesting, trust me. I'm gonna remember I sent you a worksheet. I want you to open that one. In the meantime, I think it was solving 8 sine square y equal to 7 minus 2 cos y. Now, notice that it can solve in this case. So why couldn't solve the first one? As you can see, it's giving the answer in radians. I'm going over in degrees. All right, notice right here, it gives the 300 degrees, the 60 degree. Don't worry about the plus 360n. The 360n means angles are in a circle. So what it's telling you is that in a circle, you can always spin around, right, Jamie? So what it's saying is 360 degrees make a circle. So let's say n is 0 when you don't spin around the circle. So the angle would just be 60 plus 360 times 0, which is 60. What it's then telling you is if you put in an angle like n as 1, what they're telling you is an angle like cos 60 is the same as the cos of, put n as 1, that would be 420. That's all they're telling you. Still be the same half. And even if you add another 360 to it when n is 2, it's still going to be a half. That's all the n represents. All right, but don't worry about the n's, all right? That's not on our syllabus. So as you can see, 60 is 1, 300 is 1. Now, 104.7, I will call it 104.5. So that is definitely correct. Plus 360n, then negative 104.7. And the negative 104, when you put n as 1, negative 104 plus 360, that's how you get the 255, all right? This is the one that gives the 255, because that's when n is 1, right?
That's right.
So that's how you know that you're definitely correct. So what I want you to observe is from the 3 questions, Jamie, notice the first one tested your skills of factorization. You had to realize that you had something in common to factor out and solve it. This one tested your factoring skills. This question tested your knowledge to be able to divide through. This tested our knowledge of knowing the fact that sine over cos is tan. That's why I say you must remember them. And likewise, this last one tested our knowledge of remembering that sine square plus cos square is 1, right?
Yes, sir.
So those are the 3 things they tested. Those are the only three things that they can test you for, Jamie, on integrated math. All right? Those are the only three they can test you on: factoring, sine over cos is tan, and sine square plus cos square. That's what the syllabus say. They can't put anything else on the test. So tell me from now, before we even do the next question, what do you think this one is going to test your skill on? You see cos and tan and tan.
The sine over cos.
Very good. You know that it's some sine over cos you're going to use equal tan. And it's going to end up work. So if you cross multiply the cos, you notice that you end up get sine. So we can make an equation strictly with sine, or maybe an equation strictly with cos, because we can utilize that. The second one right here, what is this testing our knowledge of? Same thing. Divide through by what? These two are similar. How do you divide through by?
By cos.
Very good. Cos to the what?
To the fifth.
Very good. Very good. Because then you get tan to the fifth minus 32, and you're good. And then this last one, testing our skills of what?
That one looks like the third one, the sine square.
Very good. But in this case, you'll just make cos square the subject, and you'd end up get cos square is 1 minus sine square. So notice it's just repetition. The first three seemed hard because you're like, whoa, it's new. But then you realize it's the same thing over and over and over again. So now, Jamie, we're just going to do 2 questions, then we close. As I said, gonna go on a run quickly. So I want you to open the document I sent you, the worksheet, not document, not the, well, let me see. How many questions did I have in the notes? Because I had some in the notes. All right, you can open, it doesn't matter. You can open the notes question if you want, or the worksheet document. It's just some question I want you to do, some additional questions. So you can open the trigonometry notes document or the other one. As soon as you open, share your screen. All right, so you can go to, I think it's page way down. Next one, question 2. We don't do radians yet, this one. All right, so I want you to do question, I want you to do one of each. So I want you to do a sine, a cos, and a tan. So I want you to do A. I want you to do D. I want you to do C. Yeah, and then we're finished. Very good, tan inverse of 1. Very good, but Jamie, tan is positive in 2 quadrants. You only showed me 1 possibility. He gave me the first quadrant, so the next answer is the third. Good. So 2x plus 30 can equal. Very good. All right, put the 2x plus 30 equal 225. Just for the consistency, yeah. All right, now you can solve for x. Oh, you get 75. When you bring over the 30, all right, very good. You get 7.5. That's good. All right, yeah, yes, no error. Those are correct. All right, so Jamie, you can even check it with a calculator. You can put in x as 97.5. 2 times 97.5 is 195. So put in tan 195 plus 30 in bracket. Guarantee you're gonna get the 1.
Yeah, I got one.
Yeah, nice. So you see both of those are correct, all right? Lovely. So do now D. You can do D on the white screen because I know there's not enough space on the page. So that is sine a half x plus 18 is 0.572.
Yeah.
All right, now I'm looking at this and looking at the question now. Look back at what the question had said, Jamie. The original question, the wording was there. They gave something important. They said x is between.
Between 0 and 180.
So in that case, the 254 would not be valid. Very good. You just write underneath it, not valid, or you can say inadmissible. However, in any synonym you have to say not valid in this case, you can use. All right, so then that is the only one that's the answer. All right, good. I'll try the last one for me now. You have a good grasp of it, which is good. All right, check here. Yeah, that's correct. 22 point, roughly 3. Yeah. Following the instruction to 1 decimal place. Very good. Reading the instruction. All right, so how do you feel about the first trigonometry? Trigonometry is a nice topic so far, right?
It's not my favorite, but it's interesting.
Not your favorite, but it's interesting. All right, good. I like that you say it's interesting. All right, so I'm going to send you this worksheet so you can practice. Maybe you want to just do some question in advance, and you can also do some of the other questions that's there in the notes and the worksheet that I sent, the other worksheet question. Next week, what we're going to be doing is we're going to be looking at radians, converting from degrees to radians. Then we're going to go back to solving trig equations, but now we're going to solve trig equations in radians. All right?
Yes, sir.
So that's next week. And then hopefully we have a little time to then look at the different graphs, sine, cos, and tan. All right? All right. All right. So take care, Jamie. Enjoy the rest of your evening. All right. And see you next week, Wednesday. All right?
All right. You too, sir. Thank you.
All right.